Hey everyone, welcome back to Math with Vanch. I'm Vanch and I'll be teaching you math, obviously. Now in the last video, we looked at some properties of derivatives, and I think most of us can agree that they're pretty simple and easy to remember. So in this video, we will be doing something similar and looking at the derivatives of our favorite functions. So if you're ready, I am too. Let's get started. So there are four functions in this video that we will be looking at the derivative of, and that is the sine function, the cosine function, the exponential function, and the logarithmic function. So most of us know those functions pretty well. Sine and cosine are obviously just our regular trig functions. So we have the sine of x, we have cosine of x. Of course, we have our exponential function, which is our e to the x. And then we have our logarithmic function, or in this case specifically, we'll be looking at the natural log. So ln of x. And last video we used the derivative notation d over dx, so I'll just be consistent and we'll stay with that. So we're going to look at the derivative of these four functions. And d over dx. Okay. So these four functions, I think they're going to be easier than you expect. So derivative of sine x is just going to be cosine x. Okay. Derivative of cosine x is going to be negative sine x. Ready for this one? Derivative for e to the x, or the exponential function, is just going to be the same thing. It's going to be e to the x. Pretty easy, right? Finally, derivative of ln x, something you probably won't expect, but also pretty easy. This is just going to be 1 over x. 1 over x. So I will be proving the sine x and cosine x. I will be proving these two equalities, but the ones on the bottom are a bit harder to prove and I won't be able to fit it all in this video. So I'll just leave this for some other video. But for now, in this video, I will be proving the derivative of sine x and the derivative of cosine x. So let's get on with that. So let's backtrack for a bit and just remember what a derivative is, right? So if you remember, the derivative of any function, f of x, that's basically saying the slope of f of x at a point, at any given point, right? So this is equal to the slope of f of x at any given point. Okay, so let's say that f of x equals dx. My bad. Let's say that f of x equals sine x, right? And we wanted to find the derivative of sine x. Now, I already told you that it is cosine x. That was kind of a spoiler, but we're actually going to prove it now. So to start off, let's graph sine x. Right? I'll have 1 right here, negative 1 right here. And we'll go by increments of, we'll say pi is here, 2 pi, negative 2 pi. So pi, 2 pi, negative 2 pi. And these are going to be our pi over 2's. So I think we all know what a sine function looks like, right? It's just going to be like that. Like that. This should go all the way to 1. Okay. That's a rough sketch of the sine graph. Obviously, it's not great. Pretty lopsided, actually. But anyways, I'm just going to try to clean this up a bit. So this is kind of what our sine graph looks like, right? And So let's just start doing things. So let's look at the slope at certain points, right? So first of all, we can see that the slope over here, 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 and here. The slope of the tangent line at these points is 0 because we just have a horizontal tangent line, right? So we can start off by saying this is negative 3 pi by 2. So we can say that, let's just make another graph right here. So 1, -1, negative pi, negative 2 pi, pi, and 2 pi. Okay, so this is going to be our derivative. This is where we graph our derivative, okay? So we can see that at this point, the slope of the tangent line is going to be 0. So we can comfortably say that when x is negative 3 pi over 2, which is going to be right here, the derivative value of this is just going to be 0. So we're just going to have a point right here. We can say the same thing right here for pi over 2. I mean negative pi over 2, because the slope is also 0 there. Again, we can say the same thing for pi over 2. And the same thing for 3 pi over 2. The reason that this is negative 3 pi over 2 is because it's right in between negative 2 pi and negative pi. Same thing for negative pi over 2. Same thing for pi over 2. And same thing for 3 pi over 2. So these are our zeros for this graph so far. This is where our derivative graph is going to be 0. So let's look at some other things. We can see that at this point right here, the slope looks to be, the slope's going to be negative, right? Because it's decreasing. And it looks to be about negative 1. So we can say that at negative pi is going to be negative 1 right here. Same thing at 0, but this time it's increasing, so it's going to be positive 1. Positive 1 right here. And at pi again, it looks like negative 1. So negative 1 right here. So we got some points, and if we just connected these points, we can actually see we have our cosine function. So this is kind of like not a very rigorous proof. This is more of just like a graphical proof of why the derivative of sine x equals cosine x. Because if we just kind of plot the slopes of sine x right here, because this is sine x, and this graph right here is cosine x, then we can show that the derivative of sine x is cosine x. So yeah. If you think that was confusing, then you don't have to pay attention to this. You can also just memorize this. Just memorize that the derivative of sine x is cosine x. But yeah. It's basically the same thing for the derivative of cosine x. Again, if you graph it, then you can take the slopes and then make another derivative graph. And that way we can show that the derivative of cosine x is just going to be negative sine x. I won't be proving this in this video because, it's basically the same thing. Same process, same everything. But just memorize this and just memorize this. Okay, cool. So let's do some practice problems. So I'll write out every derivative that we learned. So in the top we have the derivative of sine x is cosine x. We have the derivative of cosine x is negative sine x. the derivative of e to the x is just e to the x, and the derivative of natural log of x is just 1 over x. Okay, same list that we had before. I just wrote it all out. I will be erasing this now so I have some more space to do practice problems, but just know I will be referencing these, okay? So suppose we had f of x equals sine x plus natural log of x plus 2 e to the x, right? That's tilted again. Pretend it's straight. But anyways, suppose we wanted to take the derivative of this function. So then we do d over dx of f of x, and we do the same thing here. So if you remember from last video, we had the sum property of derivatives, right? Which is basically saying if you have addition, you can break those into separate derivative problems, right? So this is going to be the same thing as derivative of sine x plus derivative of natural log x plus the derivative of 2 times e to the x. And if you remember our constant rule, we can show that this 2 inside the e to the x can just come out of the derivative, right? So now we can evaluate this pretty easily. We can show, we know what the derivative of sine x is. That's just cosine x, right? We know what the derivative of ln x is, or natural log of x is. That's just 1 over x. And we have this 2 out front, so I'm just going to write that first. And then we know what the derivative of e to the x is, and that's just e to the x. So that's it. So remember how we had to do that whole limit thing with the as h approaches 0, that whole thing? It's not that hard. Function, we have some properties that we can use, some rules that we can use. You can do a derivative problem in seconds. So as long as you know the functions and what their derivatives are, these are really important derivatives to know, especially the sine x, cosine, exponential function, natural log function. Really good derivatives to know. I suggest you just memorize them. It'll make your life a lot easier in the class. So yeah, and definitely also memorize all the properties, like the addition property, subtraction property, constant property, all that, you know? Pretty straightforward. You'll be fine. So that is going to be all for this video. We just looked at the derivative of sine x, cosine x, exponential function, and natural log function. Just memorize them. It'll make your life a lot easier. And yeah, that would be all for this video. I hope you found it helpful. And if you had any feedback, please let me know in the comments. Otherwise, I'll see you for the next video. Bye-bye.